System of equations. Okay, so what is a system of equations? Well, it's basically multiple equations, right? Let's think about this. When they say solve, what are they saying? Well, solve for x and y, okay. Well, let's take a look at this. 3 possible scenarios can go down, right? Either we've got, because these are both linear, right? X and y are to the first power. So if I've got something like this, okay, where these lines intersect, that would be my solution. Now remember, when lines intersect, they intersect at one point. So you're going to have some x value and some y value. So for this first problem here, they're going to intersect at 5, 4. Okay? So that's when they have one solution. What happens if we have 2 lines, one like this and another one like this, and we knew those were parallel? In other words, their slopes were the same thing. Let's say for this particular example they were, I don't know, it's 3 and 3. So we know if lines have the same slope, they're parallel. If they're parallel, that means they never intersect. If they never intersect, well, they can have no solution, right? If where they touch is their solution, if they're parallel, they have no solution. So we would say for that particular one that they have no solution. And the only other scenario we could have is if I had a line like that and another line that was right on top of it, which means that those lines are exactly the same. Now you may look at it like this and they may appear to be different, but when you get it in that form, y equals mx plus b for both of them, and they're identical, then you know you're dealing with the same equation, which means they intersect there and there and there and there. In fact, they intersect a whole bunch of places, an infinite amount of times. So we would say there would be infinitely many solutions if we had 2 equations that were identical. So let's see what we got here. If we have one solution, no solution, or infinitely many solutions. What are our methods for solving? Well, 2 major ones are going to be elimination and substitution. Substitution is when you get a variable all by itself and then plug it in, like this one here. X is already all by itself. So what I'm going to do is, every time I see an X, I'm going to plug in a 4y minus 11. That'd be a good candidate for substitution. Okay? Otherwise, I'm usually going with elimination. Okay, I'm trying to think, how can I wipe out one of these variables? Well, I could multiply this by a -3 and wipe those out. Or I could multiply this bottom equation by a +2, would make this a -2y, and I'd wipe those y's out. So let's try that. Multiply this by 2. Now remember, if you multiply the left side of the equation by something, like 2 here, you gotta do the same thing to the right. Okay, we can't change an equation, but we can always multiply both sides of an equation by something. Just like we can add a number or variable to both sides of an equation, or subtract it from both sides, or divide it by both sides, right? Those are some algebraic properties of equality. So let's figure this out. 2 times 3x, 6x. 2 times -y, -2y, equals 22. Now I really don't need this anymore. But what I do now is I add up those 2 equations. And I'm always trying to make sure that my x's are lined up, my y's are lined up, and my constants are lined up as well. So we get 7x equals 35, since those y's canceled out. Divide both sides by 7, x equals 5. So now all I got to do is go back in one of my original 2 equations and plug in, or substitute, x equals 5. So let's take a look at this. Why don't we look at this first equation here? X plus 2y equals 13. let's plug in 5 for x. So we get 5 plus 2y equals 13. Subtract 5 from both sides. 2y equals 8. Divide both sides by 2. Y equals 4. And that is all. Okay, let's look at this one here. So, like I said, x is already all by itself. This is a prime candidate for substitution. Every time I see an x, I can plug in a 4y minus 11, since that's what we define x to be. So, 2 times quantity 4y minus 11 equals negative 8. Distribute. 8y minus 22 equals negative 8. 8y equals, oh, what did I miss? Gotta go back. 2 times quantity x minus 2 times quantity 4y minus 11 is that. Then I gotta subtract y from that thing. Subtract y equals negative 8. Okay. So I get 8y minus 22 minus y equals negative 8. Always looking to get like terms together. 8y minus y. 7y. Let's add that 22 to both sides to make 14. Then I get y is equal to 2. Now if we know y is equal to 2, I can choose either the original equation and plug y in. Since this one has already got x all by itself, let's plug it in there. So we got x is equal to 4y minus 11. I know what y is, so let's plug that in. X is equal to 4 times 2 minus 11. So x equals 8 minus 11. X equals negative 3. Okay. Another one here. Y is already by itself. Why not just substitute that in there? Another way of saying y is 3x plus 1. So every time I see y, I'm going to plug in a 3x plus 1. So 7x minus 2 times 3x plus 1 equals 1. Distribute. 7x minus 6x minus 2 equals 1. Then we get x equals 3. Alright, well if x equals 3, let's plug it back in right here to figure out what y is. So y is equal to 3x plus 1. Y is equal to 3 times what we know about x now is 3 plus 1. So y is equal to 7. Okay? That's not true. 3 times 3 is not 6. 3 times 3 is 9. I did not pass first grade. So y is equal to 10. There we go. Looks a little better. Alright. Probably not going to choose substitution for this one because I would have to get a variable all by itself, and if I did that I'd have some messy fractions. So what I think I'm going to do is elimination, but if we do elimination I want to have my x's lined up, my y's will line up, and my constants lined up. But these equal signs need to be lined up too. So I'm going to keep the first one the way it is. I'm going to rewrite this second one here. 3x is fine where it's at. Let's move this 7y to the left side of the equation, just like it is up here. So that'd be minus 7y. Now I got my equal sign, equals 35. So I really don't need that anymore. Okay. So we still got the system here. Let's try to wipe out one of these variables using elimination. And see how this has a positive and this has a minus. Let's just go with that. So I'm trying to figure out what's the smallest number that 4 and 7 go into. Well, I'll take the biggest number and start doubling it, right? We're finding, so 7 times 2 is 14. No, 4 doesn't go into 14. How about 21? No, how about 28? Yeah, 4 going to 28. So, what do I got to multiply this equation by to make this into a 28? Well, it's a 4. So I got to do it to both sides. And then I look at this other equation up here. What do I have to multiply this 4y in order to make it 28? Well, I need a 7. So multiply the left by 7 and the right by 7. And now we multiply and see what we got. So 7 times 5x, 35x. 7 times 4y, positive 28y, equals, we got to figure out what 27 times 7 is, which is 189. Okay, and then we're going to do this one here. 4 times 3x is 12x. 4 times negative 7y, negative 28y. Notice these will eliminate now. That's what we're trying to do there. And equals 35 times 4 is going to be 140. After we do that, we can just add them up. 35x and 12x, what's that make? A 47x. Those are gone. And then we got 189 plus 140. What does that come to? 329. Divide both sides by 47, and we get x is equal to 7. And then you just got to go back and plug it in either the original equations. It really doesn't matter. So let's do the first one. 5x plus 4y equals 27. We know what x is, that's 7. So I'm going to do 5 times this 7 right here plus 4y equals 27. So we get 35 plus 4y equals 27. Then you do 27 minus that 35 over there. And what does that come to? 8. Negative 8. 4y equals negative 8. Divide both sides by 4. Y equals negative 2. So our solution would be x equals 7, y equals negative 2. In other words, these two lines would intersect. All we know right now is they would intersect at 7, negative 2. And that's all. Godspeed, young bloods. Go in peace.